Welcome back, ladies and gentlemen, to a new video about Alusus programming language. In this video, we'll continue what we started in the previous video, which is to give a practical introduction about Alusus programming language and how to use it to build full-stack web applications. In the previous video, which I'll leave the link for in the description for those of you who haven't watched it yet, in that video, we built a simple web app, which is a simple to-do app, and it has a front end and a back end, but it does not have any database, so it lacks real persistence of the data. And in this video, we'll build on that by adding a database to that app, so we can actually persist the data. The app we built in that previous video is uploaded to GitHub, and under this this repo, github.com/sarmatka/todos app, and I'll leave the link to this in the description as well. But I have this app already on my machine, so I'll just switch to Warsha and to the IDE, and then look at the app. So let's start first by running the app to see how it looks before we look into the code. And you just give it Alusus and give it the file name, and then it's here. So this is the app. So you have the list of to-do items, and then you can obviously these few items are hard-coded, so you can add new ones. Let's say buy a laptop, and click add, and it shows up here. Now if I refresh the page, it's still here, but if I restart the app, then refresh, then I lost that change. So this is the part that we're gonna fix in this video, and we'll maybe depend. Let's try to also use Cloud for this and see how it does. But it's actually a simple change, so we can actually also just do it ourselves. But let's see what Cloud does. So let's start by launching Cloud. Yes, I trust this video. Sorry, through this repo, not this video, but okay, it took a long time, not sure why, but here it is. So let's start by telling it, well, before we tell it anything, let's look at the code and see what it does. So right now we have in the backend storage, we have this array. It's a hard-coded array. I mean, it has some hard-coded items, but then this array is used in the get endpoint to return the list of items. I believe it returns it as a JSON, yeah, as a JSON array, and then in the post it basically adds items to it. So what do we want? And then I don't want to go into all the front end. We've went through that in the previous video. You can watch that, and we're not going to touch that in this video. We're just going to touch the backend. So what do we want to tell Cloud? We want to tell it to replace the to-do items with a database. So let's say replace the to-do items array with a database model in order to persist the data in the database instead of keeping it in memory. Now I want to give it a little bit more details about what library to use. So I'll tell it to use the Rows ORM library to do this. Let's see how it does. If it doesn't, I don't know why it needs to access my credentials. I'm gonna cancel that. So let's see if it does well. If it doesn't well, we can give it a link to a specific example and tell it to follow the same approach. But yeah, let's start with seeing how it does. So let's starting by reading description about the Rows ORM library. There are plenty of examples in there, so it should be able to look at those and follow the same approach. I'm not sure why it's telling request failed. Let's see what this is. Why would this fail? we've renamed the file to be uppercase to just follow the same, like the standard, so that's why it didn't find it. But it should have been able to just find it. I mean, this is the README. If it fetched the main page of in GitHub, it will, or the repo itself, the files in the repo, it should see the file exist. But anyway, let's see what it does. So it's using SQLite 3. Okay, that's fine. That saves us from having to spin up a database server. So let's say yes. And again, it's trying to fetch from GitHub for some reason. All right, let's see what it does. So it defined a class, called it to do, gave it an ID, which is a primary key, and gave it a text, which is a varchar of 500. That looks good. Initialize the database. It gave it a DB schema, gave it the name of the table, tell it to migrate. That all looks good. And then send existing data if database is empty. All right, so it's, I don't think we need this. Let's say yes, but we'll just remove that afterwards. Let's start with a fresh, I mean, that was just an example, so there's no point in filling the database, because you can just run the app and fill the database manually. But for simplicity, I'll just manually remove it. So let's see what it's doing here. So, and instead of, or it's doing, first of all, it's reading all items from that table, and then it's looping on that item and fetching the text from that instead. That looks good. And then in the, I guess this is the post, instead of doing to-dos.add, it's doing now defining a to-do item, setting the text, and then doing db save to-do. All right, that looks good as well. Okay, it's done. So first of all, let's reload. Let's remove the seed. We don't need it. We're starting with a fresh database. Let's look at the table. So I like to put this in its own line for readability. So it's a not null, it's a primary key. We don't need not null if it's a primary key. It's an integer. It doesn't have so it's not an auto increment field. So that means when we, let's replace this with I prefer to use a string for this and use a UUID for the ID instead of just a number, an integer. So let's tell it to do that. Okay. Replace the ID field with or change, let's say, change the type of the ID field from integer to UUID. Use the UUID lib for generating UUIDs. So now it should go and add a new, yeah, it's looking for this new library. So the reason it initially looked for the wrong file names, the wrong README names, is because we have it, I think we have it listed here. No, we don't. But yeah, I don't know why it got the wrong file name. It used to be README with lowercase, but then it got renamed to uppercase because that's more of a standard. But for some reason, it was able to to see that old names. Okay, so it's looking for examples from this other repo. Error editing file. That's strange error, but no. This is probably because we made changes afterwards. Anyway, okay, import this library, looks good. All right, okay, so it's trying to do a migration. What we don't need to do migration. I also don't want to get into migrations in this video. I'll have a separate video just dedicated for migrations, a bigger subject. So I'm just gonna say don't update the version. We don't have any data to lose, so we can start fresh. All right, so now it added non-null. Again, we don't need it because it's a primary key. It's a varchar of 36 characters. That's correct. It's a string. All that looks good to me. So it added this function to generate a UUID. It just used the example from the UUID library. The UUID library is just a binding for the lib UUID Linux library. So that looks good. And here it just set the ID to generate a UUID. All that looks correct. And then did the same here. That looks correct as well. So I think it's done, but let's take a look at the code in the meantime. So again, we don't need this because it's a primary key. I'll remove it. We don't need all of that seeding. I'll comment it out, but eventually I'll just remove it maybe completely. And that should be it. So it's done. Let's go back there. Let's save and let's restart the app and see if that did the trick. Wait, what? It's looking, it couldn't find this file. That's because where did it get that from? That's wrong. It should be drivers / SQLite. Okay. Sorry about the error messages. I have the language set differently on my environment. Let's see if this fixes it. Sorry, maybe I need to set language. There you go. Okay, so no valid match was found for the given type. This is on line 35. Okay, that's just because we haven't done use, so we just need to say rows dot, and anything else. Let's see, let's try again and see what else remains. So it did start and then it's erroring out. Provided arguments do not match signature on line 64. Yes, that's because when you read from a library, you need it returns assert ref. It returns refs of items. Let's see, are we doing any db dot? This is a save, so that's fine. Okay, let's see if that fixes it. Unknown symbol on line 14. What do we have? Same thing. Rows dot. And then again, I think this will fix all things, I think. No, still we have more things. 27. This is UID dot. And then okay, hopefully this is the last of it. Let's see. Okay, so that's interesting and encouraging. I mean, let's reload. We don't have anything yet. By groceries, add. Okay, do the laundry. Okay, so let's reload the page, and that didn't bring me anything. So let's see. So we got the database file created. We can look into that to see if I believe the data is already there, but actually I don't see any query for loading the data. Did he update that? So in the to-do item, let's see, are we, so we're doing a get on this, and this is happening in the main. After we create the UI, we call this endpoint, and that endpoint is this. So from db select, db is defined here. Oh, I think I know why. This is tricky. Okay, so the reason it failed is because we are initializing the library directly with giving it an actual driver. Now the problem here is that Alusus is multi-threaded, and when we run the fetch endpoint, it could be hitting a different thread, and if a different thread might be missing the driver, because we have the library uses local storage. So I believe this is the issue, but anyway, let's try to fix that and see if that's actually the cause. So instead of giving it the driver directly, let's give it a closure that takes a driver which is a reference of a shared ref of type rows.driver, and then in there we do d equals so we set, and then this is the closing for the closure. That should be it. So this will guarantee that for each thread we'll create a separate driver. I'm actually not sure how SQLite behave in the case of multiple threads, but let's see what we get. So reload. Select from to-dos. Okay, so it is doing the fetch. Let's add something. Buy groceries. It did the insert, so let's reload the page. Yeah, now it worked. Okay, so let's add something else. Do the laundry and reload the page. Now, if we stop and restart the app, we should continue to have the data. Okay, let's hard refresh, and there we have it. We have all the data. Okay, so now let's look at the code and see what the code looks like and explain how this library is used. We start by importing the library and importing the driver that we need from it. The library supports multiple backend types, SQLite, MySQL, and Postgres. And so we'll have to specify which one we need so that it only loads the libraries specific to that one. And in this case, it's SQLite. The table itself, defining the model, is very simple. You just specify or create a class, give it whatever name you want, and then you mark it with the model modifier, and then give that modifier the name of the table in the database. In this case, it's going to be named to-dos. And you give it a version number. In this case, it's version 1. I'll speak about versions in a separate video. This is related to database migrations, and it's worth its own video. You start every model with this text. This is a macro that defines some essentials for that model, like a save method, for example. And then you define your two fields for that table. Each of these fields needs to be marked with a column attribute or modifier. If you have an extra field that isn't marked with a column, then it's going to be ignored by the library, and it's going to be treated as just a variable for holding some temporary data or whatever within your code, but not something to be synced with the database. So in this case, we have only two properties, and both of them are synced to the database. Both of them need the column attributes. In this case, the name of the field in the database is going to be the same name as the variable name, which is ID, but you can specify a different name, like you can say identifier, for example, if you want. But anyway, in this case, this name is fine. And then you give it the type. It's a varchar. And for the first one, we gave it a primary key. And this makes this field a primary key. For the second one, we actually need to have not null. We need to make sure that this is never going to be null. But anyway, this is just affects how the database table is created. It's not going to affect anything on the code side. When we initialize the database, we create an object of type rows.db. We give it a closure. This is so that every instance, the rows.db class internally uses a driver to do the actual connection to the database. And the driver is stored in a thread specific or thread local storage. And this is so that you can allow multi-threading. So we want to make sure that each thread runs its own copy or its own instance of the driver. We don't want to use the same driver across multiple threads, because the driver could be fetching data, and another thread, if the other thread is, and like when it fetches data, there are some shared storages used for that, specific to that driver. So we don't want that shared storage to be, or that storage to be shared across multiple threads. So that's why we want to make sure that each thread has its own instance of the driver. And so instead of giving it a driver, we give it a closure that generates the driver, that creates the driver. In this case, it's a closure that receives a reference, and then it updates the reference by creating a new SQLite driver, giving it the name of the database. And then at the end, you do db.schema builder, give it the name of the table, and then do migrate. So this between the or this template argument specifies basically the shape, the schema of your database. In our case, the database is just a single file, so the schema is just that model. But if you have multiple models, let's say if you have a user model, then you can define db schema, give it whatever name you want, curly bracket, and then inside here you specify the list of tables to do item and then user, for example, and then you can copy this and give it here instead. So you can do this. In our case, we just have a single table, so we don't need to do that, and we're just going to keep the table name directly. And that's it for creating your database. And the next step is to read data from the database, which is just to do db, and that's basically the name of the variable, of the db variable, and then db.from, give it the table name where you want to read from, and then you do select, and that's it. That brings all the record that matches your query. All the records are going to be returned as an array of shared references of the object type. So this is the type that you specify in the template argument, and then it returns a shared reference to that, and returns an array of those, because there could be multiple records. And then it all, obviously, when you receive that data, it has, or that instance of the class, it has all the data already mapped into the right column, that right member variables. And then you can just use it as you use any other object. You can make changes, and then you can do todos.save, for example. Like you can like load something. Let's say if you're updating, you can say todos of I dot text equals something else, and then you can do todos I dot save. So you can do things like that. It's just like you can do with any other ORM, pretty much. For creating records, it's also pretty straightforward. You define an object, you give it the type of the object, you set the attributes of that object, and then you do db.save and then give it the type of the object you're saving, and then give it the actual object. And that's pretty much it. That's how you read and write from the database. Now, the other thing you might want to do, I guess it's not going to be needed for this specific example, but I'm just going to mention it here in the code. But let's say you want to filter the data you're receiving. So let's say you're getting a specific record, so you can do db.from.where, and then you give it, let's say you have let's say you have a date field, then you can do something like sorry, this has to be square bracket, and then you give it, let's say, timestamp is greater than requested timestamp, for example. So this is going to be the name of the field in the database, which matches the name of the variable in the class, and then you give it whatever you're comparing against. So you can do greater, less or equal. You can do equals. You can do not equal, just like you would expect. Or you can do multiple things, like you can say timestamp is less than, and user ID equals my user ID, for example, things like that. And then you can also do ordering. So you can say, let's just put this in a new line so that it's readable. So db.from.where, this is our where clause, and then you can say .order, and you can say order by timestamp. Sorry. Or you can do order timestamp and give it minus, which will make it order descending instead of ascending. And then at the end, you tell it select. Or you can say, if you're not doing select, you can do delete, for example. You delete certain records of certain, obviously you don't need order when you do delete. But yeah, that's how you use the ORM. It's pretty nice, pretty readable. And yeah, the nice thing here is that if you've used things like ORMs in JavaScript, you'll probably have seen or experienced the pain point of specifying where clauses there, where it's pretty. You give it an object, a nested object, an object tree, basically, just to specify a where clause, which is very unreadable. Whereas here you just really give it an expression like you do in the language itself. So it's very decent. And the other thing that's important to know here is that this processing, all this processing, that generates the query itself. All this happens at compile time, not at runtime. So converting basically this where clause, doing ordering, all that generation of the query itself happens at compile time, and then it gets converted into basically a query with what do you call it, like replacement arguments. There's a term for it that I forgot, but anyway, it converts into a query that then gets at runtime with placeholders that gets replaced at runtime. So this saves some of the processing and improves performance, especially if you have a very busy website with thousands of requests per second. That's going to be performing better than other languages. And again, this is all running in low level, like C level of kind of low level, so it's pretty high performance. So I'm going to undo these changes because we don't need them for this specific example. In this case, it's just a simple to-do app. And let's make sure I didn't break anything. And let's reload. And there you have it. That is our to-do app now improved to be able to persist to the database. As I mentioned, I'll have future videos about multiple things. One of them is the migrations. So if you haven't subscribed to the channel, subscribe so you can get those new videos or get notified about those new videos. Thanks again for watching, and have a good day.